Hello everybody, and welcome to exercise 6 on page 17 of the workbook. Let's take a minute just to read this question together. So they're giving us a function f of x. Formula is given to the right, and they'd like us to calculate a bunch of limits here, it looks like. Okay, and notice that f of x is one of these so-called piecewise functions. It has a formula that's given to us in three parts, and which of those three formulas we use depends on the value of x that we're plugging in. We'll kind of take that into consideration as we're doing these limits. Okay, so let's start with part A up here. The limit as x goes to 1 from the left-hand side of f of x. Okay, to do that limit, we have to decide which of the three formulas we want to use. Okay, so pay attention here to what we're approaching. We're approaching 1 from the left-hand side, which means we're talking about x values that are a little bit less than 1. Which of the three branches in our function over here to the right would work for x values that are a little bit less than 1? Well, if you think about it, that's going to have to be this one, where x is less than 1. That tells us that what we want to use is x squared minus 3. So in calculating this limit, we're really taking the limit of x squared minus 3. And once we made that observation, we can just substitute in the number that we're approaching. X is approaching 1, so we'll just plug 1 in. And we're going to get 1 squared minus 3, that's negative 2. That should be the value of our limit. Okay, let's move on to part B here then. Okay, kind of clear away the scratch work that we did there. Okay, so what about the limit as x approaches 1 from the right? Well, this time, we're talking about x values that are a little bit bigger than 1. And so we want to choose a branch of our function up here where x values are a little bit bigger than 1. Which branch would work in this case? Well, I think the middle one. That would describe x values that are a little bit bigger than 1, like 1.1, 1.01, etc. That means that we want to use the formula x plus 4 when we do this limit. Okay, so this is really the limit as x goes to 1 from the right of x plus 4. And since x is approaching 1, we could just substitute that 1 in for 4, and it looks like we're going to get an answer of 5 for that. Okay, and then we come to C. So the limit as x approaches 1 of f of x, this is a two-sided limit, which means that we're worried about what's happening from the right and the left-hand side of 1. Well, notice that we already calculated the two one-sided limits on either side of 1. We got negative 2 from the left-hand side, and we got 5 from the right. Are those two numbers the same? No, they're not equal to each other, and so that means that this limit in C does not exist because those two one-sided limits don't exist, or are not equal, sorry. Okay, let's see, we are halfway there, and we're looking at D now. So the limit as x goes to 3 of f of x, okay? Notice that that's also a two-sided limit, which means that to answer a question like that, we actually need to first know what's happening on the right and the left-hand side of 3 separately. So we kind of need to do two sub-calculations here. Okay, the limit as x goes to 3 from the right. That means we're going to be talking about values of x that are a little bit bigger than 3. So looking back up at our function here, which branch would go with x values that are a little bit bigger than 3? Okay, well, that would be where x is greater than or equal to 3. So for that right-sided limit, we need to use x squared minus 2. That's going to give us 3 squared minus 2, which if we do the arithmetic is going to be 7. Okay? And then what about from the other side? If we take the limit as x goes to 3 from the left. Okay, well now we're talking about x values that are a little bit less than 3, and so we're talking about this branch of our function. We're going to be using the formula x plus 4. All right, so if we substitute in x equals 3 there, we're going to get 3 plus 4, which is 7. And notice that we got the same number from the left and the right, that confirms that this two-sided limit up here exists and equals 7. Okay. And let's see, moving on to E here, what about f of 4? Okay, well there, we're not being asked to calculate a limit, just a value of our function. So which branch do we use if we want to plug in the number exactly 4? Well, 4 is greater than or equal to 3, so we want to use the x squared minus 2 branch. And so we're just going to get 4 squared minus 2. That's 16 minus 2 is 14, it looks like. Okay, and finally, the limit as x approaches 4 from the left-hand side. So we're talking about x values that are a little bit less than 4. Okay, so a little bit less than 4 would be a number like 3.9, 3.99. Notice that that's still in the third branch. So we're still talking about the formula x squared minus 2 to do this. Okay, so we are going to get 4 squared minus 2, kind of the same calculation. Whoops, not 6, 4 squared minus 2. Same calculation as what we did up in part E, and that's going to give us the same answer of 14. Okay, and we are done.